All right, it's time to have a quick review of working with timelines. This is not only good for the things we did at the end of chapter 1 with simple interest, but also good for what we're doing with compound interest later on in chapters 3 and beyond. More importantly, though, working with timelines is probably the most fundamental concept of finance overall. It's going to pay off later on in the course in a big way for you. So you really want to make sure you've got this figured out. The key steps for doing a timeline are to draw the timeline, put all of the amounts of money onto the timeline. That includes the known amounts and the unknown ones, the X's, right? We want to put those on there too. They're still amounts of money, we just don't know what they are yet, so they still get the same treatment as everything else. When you're drawing your timeline and putting the dollar amounts on there, separate the two payment streams. And what I mean by that is usually we have two payment streams to deal with, perhaps an original set of debts and then a set of payments is going to wipe that out, or an original agreement and a new agreement that's going to replace the original ones, that sort of thing. If you put one of those on the top of the timeline and another on the bottom, it's going to be a lot easier for you later on when you're trying to sort out what gets added to what and what gets subtracted and that sort of thing. Next step, pick a focal date if we didn't already give you one. Doesn't really matter with compound interest. With simple interest, it will affect your answer slightly. So that's why we usually give you one with simple interest. But pick your focal date and draw it right on your timeline, a big arrow pointing where it is. And then draw arrows from each and every one of your dollar amounts that start with that amount and end at the focal date. You can put the arrowheads on there saying is it going left or right because that'll help you later. And then add N and I to each arrow. Based upon that timeline, now that it's done, you should be able to set up an equation of equivalence. And once you've got it set up, then you can pull out your calculator, start to do your calculations, and work through and solve for whatever's missing, maybe X or 2X or whatever it is at the end. All right, let's have a look at one. What I did was I said, look, Rob was, that's me, sitting at my desk and working on a problem, and then I got called away to a meeting. All that I left behind was my timeline, and someone's asked you if you could finish it off for me. All right. I put this together on a piece of paper as well that I've uploaded to D2L, and you can download the problem itself, like the timeline, and then just continue working on it. It should look a little bit like what I've got here on the screen. And I'm going to suggest you do that. So hit pause right now and go and download and print off the problem and take 5-10 minutes, whatever you need, to work through it and see if you can take it from this point to finish off the timeline and then work out your equation of equivalence and then solve for X and 2X as well. All right, so I'll see you in a few minutes. All right, I'm hoping you had a chance to have a look at it now, and I'm hoping it went okay. Let me start by adding on the values for I. Since we have one rate for the whole problem, I'll just write it over here on the side. I is equal to 0.02. I got that from this guy down here, didn't I? J4 is 8%. 8% quarterly means 2% every 3 months. So I is 0.02. For my values for N, I'm going to write them right on the timeline. I'm compounding quarterly. All right, so my little m here is 4. I got that from my rate. So how many times would I get to compound in 2 years? Because I'm going now from 0 up to 2. Well, 2 times 4 is 8. So I'll have 8 periods there. My next arrow that's on here already goes for a 1-year span, so N would be 4. My timeline is actually complete now because I'd already had the dollar amounts and the arrows on there. Everything else is on there already, so that's good to go. If you get a timeline that far, that's good news because you're ready to start solving it. Remember I said the next step was to write down your equation of equivalence. Well, it starts with just the general concept that our payments should be equivalent to our loan, in this case, after we've moved everything to the focal date, which is what we've done. Well, what do we have then? So the payment side I've done in green on my little picture. Maybe I should switch to green here as well. I've got a payment of X, and then there's an arrow next to it. So that means, of course, that it's going forward at 1 plus I to the power of N. Is there anything else on the bottom? I've covered this first one off, and there's this 2x down here, so it gets added. The 2x is already at the timeline. There's no arrow associated with it, so I'm done with that one as well. Then I can say equals, because I've got everything on the bottom, and now I'm going to move to the top, to the loan side of things, and I've got $10,000 there. There's an arrow there saying carry that forward or move that 8 periods into the future. That's the only thing on the top, isn't it? So that's it. I've got that done, and in fact, I've got everything done at this point. Let's go in here and start to write down some of these numbers. This first one, if I go 1.02 to the power of 4, I get 1.08243216 times x. And I've got 2x already. And that equals 10,000 times 1.02 to the power of 8, which is $11,716.59. All right, now we're getting close. Once we get to that point, sometimes people get a little bit frazzled at this point or a little stunned, and they're like, what do I do next? I've got this 1.08 weird thing times x, and then I have 2 more x. Is that 3x, or what is that? Well, all I'm saying is I've got 1.08x and another 2x, so that's going to give me 3.08243216 times x. Just that easy. If it had been 3x plus 2x, I bet you wouldn't even have hesitated. You would have said, oh, that's 5x. So just because there's decimals doesn't matter to us, and you can leave the decimals in your calculator using store and recall. Don't even have to worry about typing them in, do you? So there we go. That's all my x terms, and that equals, I've already worked that out, $11,716 and a little bit. Now how do I solve for x? Well, I just divide things through. So x by itself is going to be 11,000 divided by the 3.08, which works out to be $3,801.09. That's x. All right. That's this number right here. So we could actually write that on the timeline. In 1 year, you have to pay $3,801. What do you have to pay in 2 years? Well, that's 2x, isn't it? And so to solve for that one, we'll just multiply everything by 2. And so that second payment at the 2-year mark will be $7,602.18. Give or take a penny, depending on whether you carried all your decimals or not. Doesn't matter. And that'll be the second payment. So altogether, we'll be paying about $11,500 to pay off our $10,000 loan. That would be the loan plus interest, wouldn't it? And so that's the second amount right there. That's the end of that problem. I hope you got that far with it. You can imagine the question might have been originally, oh, Fred borrowed $10,000 at a rate of 8% compounded quarterly. He's going to pay it off with one payment in 1 year and another payment in 2 years, twice as big as the first. Can you find both payments? And that's it. I hope that worked out for you. If it didn't, well, you've just got some work to do, don't you? Back up, go back to our textbook, work through lots of these timeline problems. The same concepts hold true with simple interest as they do with compound interest. It's only the formulas that change. Make sure you're getting really good at these because this is such a fundamental piece for success later in the course. Any questions? Don't hesitate to get in touch, and I'll see you soon.